Check, check. Hey, everyone. Lazy Ben. Let's jump into some more coding. Okay. So yesterday we spent the day taking out the default allocator stuff. Today, I want to be able to get some metrics from the heap. I think I'm just going to work a little bit on reducing these global heap allocations. There's only 169 a frame at the moment. They go up and down depending on what we need to do. $314 there with the editor open. So the thing we might need a count of free list size to make sure fragmentation doesn't get too crazy as we're developing the game. So I think we're probably going to do this in the different project. We'll do it in this project here. Just delete what we were doing before. So if we go to the global heap, you can see it's got some stuff in it. It's got a counter in it at the moment. This is only really was put there for debug reasons. So how do I want to do this? I think really we want to put it directly in the heap allocator itself. We can either put it directly in the heap allocator itself or in the global heap. We have this thing called, well, we do have check free lists, which counts how many blocks there are in the free list. I reckon this could return a block count, potentially. Potentially. A lot of these are free functions. No, this calls check free lists. So maybe we do have heap stats, some kind of heap stats structure here. Okay, let's start with this anyway. We'll put it there. So we want void empty. And that's just going to do bmm set this 0 size of heap stats. And we're going to have size t or u64 malloc counter. Free counter. Free list size. Then we want like U64 mallocs this frame. Freeze this frame. And we might do void next frame. It says mallocs this frame equals freeze this frame is 0. So that's just going to go up and down all the time. Well, we could just count them. Okay. I don't know if that's going to be any use. I think we'll have malloc counter which we'll deduct when we're free. We will decrease by 1 when we're free. We'll increase by 1 when we're malloc. We'll decrease 1 when we're free. So we're going to call this free block counter. Okay, we'll have those. And then we'll just have heap stats like that. So we want to put a little macro in just to say, do we want to use free stats? We'll just say define use heap stats. If def use heap stats. And if create heap stats. So we could swap it. We could turn it off if we want to, like in the release build or in the shipping build. We might want to turn it off. I don't think we'll ever need to empty it. So we'll just say next frame. We might just make it public. Okay, malloc. So we're going to say if create heap stats stats.malloc counter plus plus, and then on a free, not here, well, that calls malloc actually. Free malloc counter minus minus. I'm going to go beam assert stats.malloc counter, maybe. Insmod 32 morning, how's it going? Hope you're alright. Just working on a little bit more engine-y stuff. I'm just wanting to create some stats to do with heap allocation, so as the game gets more complicated I can just see a little bit more what's happening with the global heap in the engine. Fixing bugs for your boss, lovely. Hope it's going alright. I'm on less of a gameplay. I've been working on gameplay for a long time, so I'm just taking a little break. I just finished combat prototype, just taking a little break from gameplay. Just working on a few nice to haves for the engine really. So one of them is reduce dynamic memory allocation, which I've done a little bit of work on the past few days now. And now I'm just going to create some counters just so I can see. Hopefully I'll be able to see if the heap's getting fragmented. And this might make it quite a lot easier to see if the heap's blowing up, which might indicate a memory leak, you know. Just some really crude counters really at the moment. Yeah, I hope your boss fixing bugs for your boss is going well. You align the return to memory. So I'm aligning returns. I'm aligning it. Where are we doing that? By 16 because I was getting crashes when the compiler wanted to put stuff in XMM registers. Because obviously they need to be aligned to 16 and the compiler was wanting to create assembly that puts stuff into XMM registers. So I have to align it by 16. I'm pretty sure, I'm not sure, but I'm pretty sure that malloc will align your memory to 16 or maybe 8. But I wouldn't do it if it didn't crash. But yeah, I'm making sure that it has, if you return it, the addresses end with a 0, basically. So we have also this check free lists. This is a debug call, but it does count all of the blocks in all of the free lists. So I think we're having get that return a size T. Yeah. So now that can return the size of the all the blocks in the free lists, which means when we do malloc, when we check the free lists, we can do stats free block counter is that. Well, let's do auto free list block count. I'm just going to go if create heap stats. We'll just do that, and then we need to actually do this. I'm sure we check the free lists on free as well. Yeah. Okay. Let's check the builds. So what we might do is just to get stats. So if def create heap stats, I think we can just say if, to be fair. So if create heap stats, we're just going to say heap stats get heap or get stats, and that just returns get heap get stats, else heap stats get stats, return heap stats. Maybe we'll put this here. Back to your question, my boss is stressed about customers, so I need to make sure some things have the correct result. All right, okay. Good luck with it. Yeah, I spent a lot of yesterday, or half of yesterday, debugging. I've just extended my string class to do small string optimization to reduce heap allocations. So I spent a lot of yesterday just going through all that, trying to make it work, basically. It works fine now, it's good. No problem, insmod. But yeah, so the strings in the engine now we'll use. So you can do small string optimization, so you can give them a little buffer so they don't have to dynamically allocate the string, which cut down the amount of memory allocations a lot. And then I made it so you can give it any size buffer. So I made something called an N string. And you can just give it a buffer size. So you can have like 128 bytes string if you want. So that just means that you can stack allocate 128 bytes of string data in there if you want to. If the strings are more than 128 bytes, it'll heap allocate. So this could be useful. Like the heap allocator is fast, so it should be okay to heap allocate the strings. It's just fragmentation really. I'm trying to reduce fragmentation. I'll do some work so I don't have to fragment the heap with small strings. Yeah. It's how standard string works, except as far as I'm aware, you can't tell it how big you want the buffer to be. It's just 16 bytes in the standard. So 16 characters or 8 characters if it's a wide string. So I've just extended it a little bit so you can actually create your own like the end string with your own buffer sizes. Okay. So we should in theory be able to get some stuff now. So I'm going to take the counter away because that was only there for a little quick check that I did. So we need another one which calls next frame on the heap. He's a static actually. Static void next frame. Can't be const if it's static. And we're just going to stats.next frame. Otherwise, just don't do anything. So I need the next frame because I need to malloc this frame and freeze this frame. So this is stats freeze this frame plus plus. This stats.malloc this frame plus plus. Yeah, that's right. So it grabs pages using BM page alloc, which is virtual alloc on Windows. It would be a different mechanism on a different operating system. And you just pass. So we've got a minimum page size. So you want 8,000 blocks with 32 heap blocks. Or 32 size of heap blocks. 32 blocks. So I can't remember. It's maybe like 16 meg or something. So it grabs multiple megabytes at once. Puts them in a page, and then the heap allocator will use that page up until it's used up. And then if it needs to allocate another one, it will allocate another one. Yeah. Previous engines I've just like allocated like a gigabyte and then carved off that gigabyte, you know. This one I've gone a bit more piecemeal and divided it into pages. And that means that if pages aren't ever, if the entire page gets freed, it can free it back give it back to the OS, but I don't think I actually implemented that bit. I don't think it does. It's just basically it just allocates until it runs out of memory at the moment. But in theory, you could detect when a full page is free and then free that page back to the OS if you wanted to. I left it open so I could do that. If I ever need to. The thing is, like, I don't think I'll ever need to do that. Memory's so rigorously reused. Okay, no problem. All right. We've got count committed bytes there as well, which might be interesting. So what does that do? It gets all the pages and deducts everything from the free list. Maybe we should put that in the stats as well. This is something called a scoped memory counter. Oh, that's a little thing that I use to see what heap allocations a given scope did. But what I might do is whenever you request the stats, I might do auto result equals stats, and then I might do result dot committed bytes is get dot count committed bytes. I don't want to do a count committed bytes for every memory allocation because it probably takes quite a long time to do that. Return result. I'll do it whenever we want to get the stats, which should just be once per frame. Okay, so let's swap back to the other project, to the actual game project, and we'll start using this. We'll have to take out where we were using that counter. I just need to rebuild. I've just changed. libbm is the support library and it's included everywhere. And that's what I've just added all that stuff to in the heap, so I just have to rebuild everything first. All right, cool. So we have to just take out this counter stuff. So what we're going to do, we've got HAL stats. So we're just going to rename this HAL stats because we've got more stats. HAL stats can be optional for some reason because it's a function pointer. Okay, so we'll remove this. This is specifically GPU stuff. And then we'll do auto CPU, well, memstats equals global heap get stats. So we'll call this heap stats even. So basically just got two separate draw calls here. One for memory and one for render targets. What do we need? We need to draw all these stats out. We'll just do one draw call for now. So what do we want? We'll do Allocs this frame and freeze this frame as one line. So of course this frame Allocs freeze and then this is heap stats dot Allocs this frame heap stats dot freeze this frame client bounds top left I'll just put it down a bit like 100 for now. So we've got Allocs this frame, freeze this frame, and they want global heap next frame. Okay, let's just see what happens there then. I'm gonna call this heap text. Interesting. We've got more freeze than Allocs there. 90 more freeze. Must be freeing a lot of null pointers. $169 Allocs, 259 freeze. Okay. I wonder if I should test there if it's null pointer rather than straight going to here. I bet a bunch of them are null. That might be a way to do it. So we could actually assert there that it's not null. And then in the global heap itself, so we could do like, if size equals 0, return null pointer. If pointer equals null pointer, return. And then we can do bm assert size. And then on free, we can bm assert pointer. So realloc has to do it as well. So what happens if you've allocated something and you want to reallocate 0? What do you do there? So I'm going to say if size equals 0, return null pointer. We'll just say that you can't do that. Okay then. So now let's just see what happens. All right, now they match. So we're going to go heap this frame, global heap, well, heap this frame, and then just do this. And then heap. What do we want? We want malloc counter, free block counter, committed bytes. net malloc. Net mallocs. Free block counts. Let me just say 132. We went from plus 40 there. So what we're doing there, we're going 4 and then 40. So it's 36. So it'll be 136. So this is the net mallocing we're doing. So this, if this goes up, in theory, it's a memory leak, right? It means we're allocating more times than we are freeing. So we've done 18,251 mallocs. There's 70 blocks in the free list, which is actually pretty small. That's pretty good. That is really quite good. And it's not going up, which means we're not immediately fragmenting it. Only 43 free blocks. That's pretty tidy heath, that. I think we do want to actually we only want to actually update the stats probably once a second, or once every half a second or something, to stop these flickerings happening. What it means is if net malloc is going up, we will see that's a memory leak. Let's do something a little bit more complicated with the allocations. So net mallocs are going up there, but we are creating stuff. Still only 42 free blocks. The free list is really small, which means that a lot of the blocks are getting reused again. I'm happy with that. Okay, so let's just do auto y offset equals 4. This is Y offset plus equals 30. So we'll just do this for every single line. Was it 32? Then we will do one more. With the committed bytes. Heap. Oops. How do you spell committed? Committed bytes. Check that's how you spell committed. Yeah. So this is like this. Committed megabytes. That's committed bytes text. Didn't like that. Have to be a float. Has to be a float. $230 megabytes. Need a top left align text there as well. So it's only committed 200 megabytes. It's pretty small. And 200 megabytes of GPU stack, GPU heap as well. It's amazing it's the same. That seems kind of wrong. Let's just do auto x offset. Weird that is in the wrong place. What is going on there? Heap this frame. Allocs 169, freeze 169. Net Allocs 18,247. Free block count 5859. So it's recycling the last block. Heap committed megabytes 230. It is a mental coincidence that there's 230 megabytes allocated on the GPU as well. GPU is going up now because we're starting to do more graphicsy stuff. A little rendering bug. There's a gap there. That's confusing. It's got obviously to do with this. Can we just not pass it? So let's just not pass these. It's to do because that takes into account the size of the actual string, or vertically. And we don't want to do that. So what do we need? Font size, text. I'm not passing in even the text. Mem text, RT text. Heap this frame text. Heap frame text. Heap committed bytes text. Okay. Oh dear. Missed out the comma there. There we go, that's better. We will spread them out. We'll just say auto vgap equals get, what is it, STF font, get line height, font size, medium. And instead of plus 32 here, I'll just do the V gap there like that. What I need to do is, when we draw a string, we need to have one that actually we can put the new line character in. I wonder if we can put the new line character in. No, it's just meant for a line of text. All right, there we go. So we've got some nice memory stats in the top there. So we could include the temp arena stuff as well. You know what the temp arena is? The temp arena, if the temp arena starts blowing up, it'll show in the heap stats. So maybe that's fine. Heap this frame. Heap frame's kind of the wrong word. So we're just going to probably put this at the bottom. With canvas. So I think we'll probably put canvas right at the top. And then we won't need to do it there. So now it'd be nice to kind of see where these actual mallocs are coming from. Or do we want to actually update them? So that's updating them every frame. Maybe we want to update them like every T amount of time. So what we can do is we can go static heap stats. Heap stats. And then we can just go static T equals, we'll say every half a second. And then we just go T equals BM not neg T minus DT. T is equal to 0. Do that. And then we'll just say T is equal to 0.5 again. So that'll just update heap stats every half a second. The thing about that is we do miss, obviously, a bunch of heap stats in the in-between frames. But we're only really looking for the change, really. We're just looking for things blowing up. They're getting bigger and bigger. 231 committed megabytes. So what happens if we start doing crazy stuff with the editor? So let's make a huge pond. So it went up to 414. That's just because the editor's open. We can do something with rivers. Whereby we can put gaps in them. Somehow I have to remember how to do this. How do I do this? There we go. Press the Alt key. So we can do like a gap there and a gap there. And then we can just color them individually so we can make that one a bit whiter. Well, purple. And that one be a bit greener. Anyway, you're messing about there. Let's delete the. Let's save that river. It's a nice river. Put some more ground underneath it. All right. Let's just see now. So this is going to include an asset compile, which might mean there is a lot more committed memory. We'll see. Because the engine's got to build all that river into the level and stuff. Or I might free it. No, it's totally fine. I'm really pleased with that. Like, we do a lot more free blocks. 155 free blocks. So if we change it, if we build the game while the editor is running, what does that do? $173 blocks. Oh. Yeah, I think I'm alright with that. I think that's fine. So how we perform wise on this as well. We're just going to do a lot more stuff now. So what are we actually seeing there? What is this? This is like me marking out a plantable zone, I think. Nav mesh regions mode. Interesting. I'll probably change that to a drop down box actually. All right. So it would be good to see where a lot of these are coming from. Let's just check in what we've done. Like a lot of these are coming up from strings, maybe. But there's not that many. Maybe we just leave it and call it fine. And work on something else. Okay, so this is running job with a lambda. DX state run job dynamic lambda. Okay, so the job queue run job takes a callback type. Job queue base. Dynamic lambda. So let's change this to a hybrid lambda. See what this does. So we're looking at roughly now, it's like 186. Seems to be stuck on 186 Allocs for the frame. Yeah, 186. So let's make this hybrid lambda 64. It was 186 before. I don't know what kind of capture list it was. So we go on DX run job. Pointer, pointer, pointer. So that's only 24. And this 32. So that should fit in the hybrid. So we knocked 6 off there. Cool. So this is coming from String Builder. String Builder. Which is coming from Pickscope. So I bet Pickscope has got quite a lot of dynamic memory allocation. So if we just don't use Pix, so it was 180 before. We only really need to turn Pix on when we want to do some GPU debugging. That we're down to 152. Okay, so this is binding shader resources. So this is mallocing into an array. Now the question is, could this be temporary array? It can be a temporary array. we just create it and get rid of it. There. Okay. Let's see what this does. Down to 151. Now, it probably means we've got to call this T. So I remember TDX12 post processor, because I remember it's temporary object. Yeah, we'll rename that. File that. Otherwise, I'll forget. And I might put one of these in, you know, some kind of global scope. Okay, so we're at 151. So we would from 186 to 151 now. Okay, where does this come? Next one. The global temporary, and there's nothing much we can do about that. That's got to. Okay, so this comes from game region. So this is when it wants to copy a game location into a game region. Now this is one of the optimizations that I had in mind actually. So a game location doesn't need the level. You can infer the level out of the room. So let's just check in. So all I'm going to do is delete level and see if it ever gets used. It doesn't need to know about the level. Let's just check any compile errors that come up now. Okay, so if we do assets, levels, the level is the first, the level name is the first folder name after assets levels. So we can actually infer what level it is. So we don't need that. Okay, so we need that. And then we could be able to, where we have the room string, make that more of a stack-based string. Car.location level. If not car.location.level, can we just say if it's not got a room now? Why were we specifically wanting to know about the level? Because it can go from room to room to room. Tick monorail car. Maybe we should do that all the time. Just set the room. Get the level. So this is... So game location has no member level. So what we need is we string view get a level. Not there though. So this needs to look. So do we have path? Get remove. So we need to go while auto head equals path remove last room to change path. No. I'm going to say if head equals levels if we look at the game config here, it's levels, but so if the head equals levels, return string view. Well, we just return head. Like that. I believe. So we need to check that. So we keep removing till we get to the levels directory, and then we return the rest of the string. So that's super duper fast. And this is just get level now. If you could somehow get the number of heap allocations to be below 100, that would be absolutely awesome. Alright, that's it. So the only bit we changed was that monorail car tick, which we could put back to get level now. Okay, we've got heap corruption now. Oh, that's because we've changed some stuff. We need to actually recompile some stuff. So I'm going to recompile, rebuild all of the game data. And I'm also I'm going to rebuild the executable as well. Because we changed the layout of location, game location, and I know that is included in quite a lot of level data in serialized form. But we'll rebuild the game executable as well, just because I've had problems with memory corruption in the past where it hasn't actually recompiled this change into all of the translation units. So we'll make sure we do a fresh build, which we're doing. I wonder if I can get the font size of this a bit bigger. Visual Studio, output window, font size. Environment fonts colors. What we're looking for. Show settings. Change show settings for to output window. That's better. That'd be better for the stream. See, look, I did a rebuild and it's got compilers in it. Yeah. So get level. Get level. Okay, so this is saving the game location. So that means we need to, all the game saves. Oh, there aren't any game saves in there at the moment. So we can get that away now. So I can actually in here change it to fire code. So it matches what I have here. Okay. I wonder actually, because we have a problem here when I do this, when I select an error, it goes. Oh, it did go blue, but now it backgrounds to white, which is awesome. It backgrounded to blue with a foreground of red text before, which meant I couldn't really read it very well. Now we can. Brill. Set location. So this is get level. Get level. Get level. Okay. So I wonder, get level, we could actually pass in a game location. That might be nice. We could go like opt_ref game level, get level, const game location. And that just return get level of location dot get level. And then let's have a look at everywhere we're calling get level. So now that can just be location. That can just be location. Comparing levels there. That can just be location. That can just be location. That can just be location. That can be location. That can be location. It's quite a good change, this. Ooh, so we've done some. Last couple were contains asset. I think contains asset we do want to not depend that, not have a location as an option there, because that's not really talking about like a location asset. Doesn't make sense in that way. All right, let's let these build. All right. So that's optional there. Get current level. Get level for the location. Location's kind of a bad name for that. It needs to be current location. There's probably loads of other stuff called location. And see how many things are called location. It's taken ages to find all the references to it. All right, let's rename it. So what's this then? Inside region. Well, we don't need to compare level anymore. Get a level. Okay, so I think it's worth probably doing a new build. Region, current location, room. It's saved. It's renamed that incorrectly. It's just location. It's not perfect, is it? This renaming thing. Same there. Okay. Keep going with the build. Okay. Game state, get level NPC location. So this is optional. So state apparently. Data. Game launch state. Oh, that's the current level. So game launch state also doesn't need the level. Just needs the room. So now we can remove this. So we need to get the level out of the room again. Do you know the game launch state? To be fair, could be a game location. That could be a game location. This is location. Get level. Alright, let's continue with the build then. So we've changed game launch state as well now. So that's going to create even more compiler errors. Level path. So this is location. Dot room. It's bar contents. Dot path. Like that. Okay, that was fine. I know, well, the BM, I know that the Sci-Fi Gardener projects can't build, surely, because we've changed the launch state. Like, we don't even know at the moment where to launch into. What room to launch into. Okay. Okay, so There's no such thing as first level now, so it's launch state location.room. Now it knows which room to launch into. Load level. It's just launch state dot location dot get level. So this is location.room. Continue with the build then. All right, we're built. Do I trust that it's built though? Because last time I actually tried to rebuild the executable, it found even more compile errors. So we'll just try that again. If this builds though, I'm going to have a coffee break for 2 minutes and I'll set the asset compiler running. Because we've deleted all the game data. So it'll need to rebuild all that, and that takes a couple of minutes to do that. And I'll go make another cup of coffee. So what we've essentially done there is we've taken out the level from game location, because we can infer the level from the room because it's just a directory. So the level is just well, actually no, the level, it would be levels / and then the level name. So we want to wind actually forward here. The asset compiler as well might want to use this. Looks like it is going to build. Yeah, it built fine. So we need to wind forward. So we found the head. And then we need to wind forward now. So it'd be like, what we're looking for is levels, but like that. So we just need to wind forward to that character. So we're going to say, we can just do it straight up pointers. So tail is equal to head plus bm_len head, or head.len length. And then we go while tail and tail is not, and so while tail and tail, well, just go straight, we'll just go through it to the end of the string. We're going to say so we'll do length plus 1, right? So that'll skip it past the slash, the first slash, because we're looking for levels, but, right? So we do past the length plus 1, so it'll start on B, right? And then we need to go while tail, and we need to go if tail is equal to /, we're going to return head.begin tail. That should do it. Head.begin. So let's just move this into the source. Is game location not have a source? Apparently not. All right. We could have one. We put a lot of stuff in there. Let's get this working first. So what we need to do is that. We actually have to wind tail on. And then we could make this like, we could experiment with making this, because this is going to be kind of a path. We could experiment in making this a fixed size, so it doesn't have to even dynamically allocate this string. see what knock-on effects it has. Because game location's included in a bunch of places, and if all of a sudden we start making it 256 bytes in size, it might blow up some of the things that do get dynamically allocated. Okay, so it's going to build the fonts and stuff now, so I'm going to go for my 2-minute break while it's doing this. But yeah, I'll be back in a couple of minutes. All right, still building fonts. I need to speed it up. Things I build fonts so rarely. I can't bother to spend time on it. So we'll just get this get level to work, and then everything else should work. There we go. Okay. So this. So we're in. It should say levels boat. Wow, look. There's an immediate problem. We want helpers. String starts with head levels. I thought it returns the actual last, but it doesn't. It just removes the last and returns the new one. Yeah, I need to put this in its own source file, so I stop triggering all these files to build. This is basically triggering almost all of the files to build. And 2 libraries doing this. All right, try again. So head, so we've got levels. The string does start with levels. So we're going to get the tail now. It's not head.length. It's bm string levels. And we are actually going to create a source file. Okay. So let's move all these into the source file. And all these. And let's build. Ooh. We created a new source file doing that. So we will put this libbm engine. What is it called? Game location. Where did it put it? There. So we want to not build it in debug mono. And then in the build 7, we'll put it in here. So this file needs neatening up a little bit. Put some, occasionally puts the namespace prefix there. And then for others it just didn't. It looks like it did on the methods, didn't on the constructors or the operators for some reason. All right, nice one. So we'll just remove these BM. See, now it only has to do build 7, which is lovely. You didn't have to build everything else. Much better. Okay. So it starts with levels. The tail now. There we go. So we're just going to go all the way through until we're at semicolon. Sorry, the forward slash. And then this returns levels, but there we go. So that's it. That works. So the game should just run now, but without that extra string in there. So that should reduce the heap allocations quite a bit now. I mean, I don't know. Ooh, or it will crash. So get level didn't work in that. So the room is empty. So what does remove last do if the room is empty? If the string is empty. Makes an empty view. So I think we're just going to go if view is empty, return view. We'll just return the view. If it's empty, we won't bother. Just do that there. Oops. There and there. So here's the thing, none of these really are checking for that. I don't think we'll do it here then. We'll say it expects valid data. If room dot is empty, return W string view. Right. Unfortunately, just messed about with the big support library there, so it has to rebuild everything. That's fine. So the next thing would be to try and make this like a bigger string. This has 16 bytes of a 16 byte buffer in there. No, it's a 16 character buffer. So this can fit up to 16 strings of up to 16 characters on the stack. We could increase that. Look at that, gone to 15. Well, it's not actually doing anything. It's not actually loaded the game in. Okay, so that is obviously where we are actually trying to launch the game. Where's the game launch state stuff? Recall begin game. Okay, this gets the launch state. So the first room is the planting room. So we do have correct launch state. And then we do execute launch game. Okay. This never fired. Weird. It's not valid. So why is it not valid? Contains asset get LST get location dot get level. It doesn't have the level in it. It's not been loaded. Not been built. Because this requires this is a name, which is a string literal. Right. So who is doing this? Okay, this should definitely be a string view. We do find asset header. Which is private. So we need to do auto str equals resolve string asset. Resolve string type. Is that what it is? Global temp arena. And then we can just do that there like that. So this wasn't an all terminated string, and it accepted a name type, which is a string literal. So it just goes right towards the end of the string. So So resolve it here, which means if we pass in something with null terminator, it's totally fine. If it doesn't, it will resolve it into an actual string with a null terminator on the temporary arena. So it still doesn't count as a memory, like a heap allocation technically. So we've got load and unload asset as well here, which is probably going to suffer from the same problem. So this make a resolved string, which will put it on a stack, which is nice. Okay. So that worked. So it did pass. So the LST, all these here, so this also needs to do a resolve. And this needs to take const blue string view. And when we call load asset with an asset header, so let's have a quick look here. This is the global temp arena as well. So actually get asset is the same. Const blue string view. Unload asset const view string view. Quick look through all these public functions then. There's not many of them really. That one. And unload. Okay. Let's get through these compilers first. So we've got BM name all shaders. We can't really do that anymore. So an asset handle has a pointer to a literal init. So we might do a load asset with a name in private. And then this one just return a load asset with maybe we call it load asset internal. Anyway. Load asset T like that. Oh, let's put that right over there. Okay, so these are W string view now. Ambiguous call to overloaded function. So that we obviously didn't put that in private. We totally did. So it's saying that BM name is inaccessible. why it's doing that. Ambiguous call. Could be load asset BM name. Load asset string view. Except load asset BM name or load asset name is meant to be private. Well, I'm going to call this internal. I'm going to call that internal. And this calls the internal version. This calls the internal version as well. Okay, let's see if it allows it here. So this needs to go past. So I wonder if an asset handle could be a string view. I wonder if it could be. Or we could just friend class the asset handle. In the LST. Try that. But the asset handler, of course, has to call load get asset internal. Get asset there. So you could just call get asset with yourself. I believe. And then the LST would naturally have to friend class it. Okay. Unload asset. View string view. Got a linker error for it. Referencing function DX pipeline. So if we go to the build for the graphics library and just rebuild this. Did that work? Okay, so it still doesn't like it. Cannot find the implementation of this one. Alright, well, let's just rebuild it. I just want to check that the asset handle comes from a file and is a literal. I think that's the case. Okay, got some more errors here. So add brain group. This has to be const w string view name. This has a name as well. Dialog group. This needs to be const string view. Both of these. So can we do a comparison with another name? But we can go from string type to name. Keep going, we'll keep going. Okay. So we actually made something that references editor fonts, do we not? Editor fonts. Assets, editor fonts. So font group. Can take a name. Patrol group. So the problem with doing this though is, well, it's not going to be around. Yeah, I don't know, maybe we need to actually... So these mapped names, so if this was a string view and we stuck it in there, it might go away. Like, I wonder if you should just take name out. Yeah, I'm not sure. Oh, we strengthen it so it has to take a literal. Oops. Doing the same here, you see. All right. So let's change these back to name. No, 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 no. Let's plow on. But the thing is, these kind of this name thing here now. Ooh, it's a bit dodgy, isn't it? It's a bit dodgy. We could do something like end string 64 like that. Maybe. And save it as a name. Like this. So we could just remove name. Now they've got this end string. Alright, let's just check this in. So I've never really liked name because of the literal thing. Hash. Let's see how we go with removing name. Quite a lot of places use name. All right. Under redo entry, we've got a name. I think we're just going to call it, which this is just going to be a W string. NW string 32 or something like that. Right. Window handle. We're just going to go NW string 32. Canvas handle is a wrapped name. I'm going to say NW string 32. Mouse button's deleter was implicitly defined as deleted. Destructor. So who is trying to delete it? Yeah, I don't know, man. So many uses of name. It's everywhere in the game. It's like literally everywhere. All right. Let's just junk this. And then let's undo all this. Undo, 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 undo. And review the commits. Might go back to that one. So where are we here? This is before we took a level out. So it's created a big knock-on effect with the name stuff. It might just be worthwhile just keeping level in there. Because it's because we were returning a view when we called get level, which was set to, and then the view is being set to a name, and the name is a literal, so it runs right to the null terminating character in the string. That was the problem. To solve this problem, we would need to return a heap allocated string for the name, for the level. We could, like, levels aren't going to be very, like, these levels are all probably going to be small names. How many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 with a null terminating character. So it's not heap allocated anyway. Here. Okay, so what I want to do so detached at 6A9. So I'm going to reset it there. Okay. So now let's just see if we can change something. So let's just move these into the source location and those. Build this. And then let's just check that in, see if we can push that. We are still ahead. Pushing to master everything up to date, it says. So this one is detached, it says. How do I reset the head? Okay. Git. We want to reset. Make current. Detached. Head. The head. Make local repository the head. Make local branch the head. Force push. View terminal. Git push F. Git push origin head. Okay, that looked like it worked. Let's just build that. Unfortunately, it means you have to redo some stuff. But that's fine. check we're actually building and running. Draw still has all of our stuff on that we did this morning. So we're gonna do. We're gonna do NW string 32 get level. I'm just gonna return it as an actual string, but hopefully on the stack, right? So we're gonna go. Auto head equals room. What is it? Yeah, so we're going to go while auto head equals path remove first room. If head, if helpers string starts with Nufako, thanks for the follow. If you got any questions, just ask, no problem. Just trying to reduce dynamic memory allocation at the moment. Little bits of optimization. Taking a quick step away from gameplay because I've been doing it for so long. Doing a little bit more engine-y type stuff now. If it starts with, if head starts with levels, we need to wind forward. So the tail is equal to head dot begin plus bm strillen levels, and then we need to do while ptail, if ptail is equal to /, we're going to return NW string 32 and we return, do we have a begin and an end? Yeah, begin and end. So that is head.begin ptail like that. If room dot is empty, we can't do this. So I might make it actually standard optional. Nah, we'll leave it. Well, okay. So let's just move that into the source file and build it. Hey, is this in Python? No, this is C++. This one, not Python. I've done Python before though, a few years ago. All right. So let's just call let's go to the game, the game state, and then we go before tick. Whoops. I'm gonna go auto level. It's location.get level. We'll see if it works. Have you done much Python? The Farco. We also have to remove game location. Where is it? From the build. And we'll include it in build 7. So we'll just check get level works. And I want it to actually return a null terminated string on the stack though. And then this solves the problem we had before. With passing it to the LST as an asset name. Okay. Get the level. So the level string is empty at there. Ooh, we had a problem. The locations room is empty. So we might also need to rebuild the game data. Again. This might take a while. Right, while this is building, I'm just going to get some water. Won't be long. 2 minutes. Right, I'm back. All right. Location's still empty though. Well, look. Okay, so we have the room. It's because the room starts with levels. How did this work before? So this is it's actually head, auto head equals room. Get view, and then it's a do while really. So this is level but, and it's a bunch of problems here, like it's so this straight up copies it in. And for some, we're doing a non-trivial copy assign into the standard optional. Okay. So I'm not going to do an optional. Just going to be the empty string. The unset string if it didn't work. And then what I might do is I just might say if head set do that. See if you can get the game back. Because it's just black screen at the moment. And I also want to double check this string class is quite new. Double check that I will always put this null terminating character in. I think it will. It's going to in place a strut of length 11. So yeah, it's going to put a null terminating character in the 11th. Well, let's just have a look. So let's have a look at buffer 100. So it's in the buffer is size 12, right? So the length is 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, so the 12th is going to be the 12th, yeah. Oh, index 11, it just puts in the null character. I think that's fine. And we have the game as well. It's awesome. Okay, so now we're returning actually a null terminated string. So we can get away with removing level, I believe now. There, there, there. Okay, so now let's just put some wires out. So now let's remove everywhere that has levels in it. So there we go. There. Uh, all right. So this is get level. Oh yeah, so yeah, get level there. And there. If not card location level. So it's not on a level. So this was just checking if the level string existed on the car location. I think we are just going to go with saying it all the time. How expensive? It's just to find an ID. That's fine. So we want we do want get level for game location. Ref game level, get level, const game location. Yeah, we do actually want to rename. So this location has to actually be called current location. A few things back in that we took out when we wound the source tree back a bit. So it's not there. Tell us, Tay, how's it going? Hope you're alright. Just working on the memory at the moment. Trying to remember that. Just trying to reduce the number of dynamic memory allocations a bit. And just write some little stat tools thing so I can just see how many dynamic memory allocations we're using and how big the free lists are. We're doing a bit more like engine-y stuff at the moment, having a bit of a break from gameplay. Those are those two. So I'm going to call this current location. Yeah, I'm glad you're doing well. I'm doing well. I'm hot. It's hot today. Well, it's been hot in the UK. It's a bit cooler today, actually. The office is very hot. Like the building is just baked. It was baked in the heat yesterday and it's still very hot. Okay. Want to join a game jam? Oh, cool. Yeah, nice one. That sounds great. Never done a game jam before. I worry that I'd be too slow. Really. Might be a little bit too stressful. Thing about me is I want zero stress when I'm coding because it's what I do to de-stress, if you know what I mean. But they do sound fun as well at the same time. Okay, so let's have a look at all these. There's only one of them. Yeah, exactly, yeah. Yeah, it sounds great. What was the theme for it? Time travel. Oh, that sounds awesome. Yeah, definitely. Okay. Let's continue to build. So you could take it like literally and have a game where you can mess about with time. A bit like Braid does. Or you could actually build it into more like the story, more like what Assassin's Creed does. Yeah. Take it from different levels. So now I'm just taking out unneeded strings. That's the plan. To reduce the allocations. I mean, there aren't that many out. There's only like 140 per frame, which is still pretty good. But it's just a nice break away from gameplay. And then maybe in the next day or two we'll start up with gameplay again. There's one more gameplay system for me to build. Prehistoric with some dinosaurs. Yeah, awesome. It's like, thing is, it's like 2 days, and you got 2 days to do it. You're not going to be able to do much. But yeah, if you like take it as your own thing and spend a bit more time on it. I have thought about like, because this is a sci-fi game, thought about incorporating some kind of time dilation element maybe into the story. Which is effectively time travel, you know. Yeah, no problem. See you in a bit. Game state, load level, data location, get level. So this is where it fell over before. It should be alright now. Okay. So I'll get build 3 built. And then need to rebuild the game data again, unfortunately. Alright, while this is happening, I'm going to go and make a cup of coffee. Back in 2 minutes. So they say, should you be using, should I, instead of using Godot, should I use Unity? Hey, how's it going? Whoa. I have not much experience in either, so I don't know. I know that ethically Godot seems, it seems to, you know, because Unity is like a for-profit company, they've often done things like make it much more expensive to use Unity. Once you've shipped a game, I mean, they've done stuff like that, so that like put me off immediately. Whereas Godot is seem like a full open source project, isn't it? That, I mean, they might go that way in the future, you don't know. But right now, it seems safer in terms of like future-proofing your games. Yeah, 1 second, yeah. Okay, so we're back. 151 Allocs, 151 freeze. So let's just have a quick look and see if we can catch a Alloc happening and where it comes from. This is the global temp arena, so that has to Alloc. This is a string. Game regions is copying over the game location. So this is where we were before. So the rooms are like paths. So it basically needs to... So what's the length of this? It's 42. The SSO size is only 16. So just for a laugh, I'm not suggesting we do this. We can make this 64 stack base string. Just see what happens. Which basically means that game location is trivially, it's like copyable. Okay. So we're calling self warp dest. A star room location. So that doesn't take. That takes a string. So NW string should, it can't go to a game that's bleh. It can't go to an A star room location implicitly there, because it has to pass through W string first. It could go to W string implicitly, but it can't go to A star room location node. I wonder how many of these problems there will be. So let's check in there. And then we'll see how far down. Whoops. What did we do there? We just... Oh, GitHub's doing something weird. Right, let's go back there. Okay. So let's see how far down this rabbit hole we get. We can always go back, can't we? So A star room location node. We're only putting location rooms in here. You know, I think actually as well, you could get away with just making a string view version. So why have we got the room? The room's probably just for debugging. So let's just remove room. See if that builds all right. Look. So it is used. I want to make it a W string view though. So it doesn't have to do any allocations. So, okay, it has to take any string type really. So we'll do template class. Well, we'll do concept static allocator size tn, and this is actually string base wcharty allocator n. That can take any string. Any wide string. Like, I think we can get away with string views. So when it puts it back together though, it's our room search result. This is just a bunch of string views. The path. And it returns the first one into an A star search result, which will put it into a string. So it's cool. I think they can just be string views, which will speed up pathfinding a little bit. I mean, not really, but we do need speed up pathfinding, so any little helps really. I'm going to do a pass over pathfinding next, speed it up. So about 151 before. Dest is null. So the world needs rebuilding by the looks of it. Okay. Let's just rebuild. Oh no, bunch stuff needs. We actually changed the game location. Again. the game location layout. So actually, a bunch of stuff needs building. We probably need to rebuild or rebuild that, 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 that. We'll rebuild the fonts again because they take ages. Hey, you alright?
Yeah.
It is warm.
Software loaded to the
Oh yeah?
new software. Yes. Final check.
That didn't work. That didn't work. So what have we changed there? Let's rebuild all the assets again. Yeah. Just open the door there. It's getting a bit hot in this office. Okay. That makes these copyable as well. So that should speed it up quite a bit. Doesn't like it, man. Doesn't like it. Doesn't like the world. Okay. I wonder if it's because no. Let's have a quick look. Shader group's fine. Font group, sound banks. More sound banks. World. Here we go. $59. Region ID, region room. It's the second one. Oh, look, we don't have a reader for the string. Ah, for the different types of string. So let's have a look at binary serializer. For W string. There isn't. Binary serializer for string. String base. Here we go. Okay. This was not implemented. That's builder, string builder. So if you go to string, where's the binary serializer for it? Do we not have binary serializer for string? We obviously have it for the default string. For just string or W string, but not for N string. N string's very new, so I obviously didn't. Obviously didn't put it in there. string builder. There's no string though. View the history of this file. I could go back a while ago. Hmm. Okay, then the only thing we've got to do then is, unfortunately, well, is there anywhere else? Anything that we decompiles a string, or that loads a string that we can look at? So it is able to load strings from binary. But not end strings. I can't find out where it's loading the string from. Quick look then. So this is a shader group. It's got a font generator for some reason. That's like doesn't even do anything, that file. Shader group has a string in it, so we can watch it load this shader group and see how it works. Here it is. So it's actually in the binary reader itself. So this is size TN. And N goes in there. Now, what about the binary writer? Looks like it just works on string views. What about the text serialization stuff? Here. Nah. That's the raw string reader version. So this is that uses the string formatters. Which I have already covered. Not here though. So this two ends here. All right. See you later. Yeah. See you there. Okay, good. Right. Now let's see if it can load it. So what was happening there is it was just trying to load the default string, which has got the SSO buffer is 16 bytes in the default string, and there was no loader for an end string where you actually set your own SSO buffer size. So it was just missing out. Don't crash on it, it just misses it out. Which obviously it led to a crash later on. So let's build. It depends whether it wrote to those files properly. I think it writes just using a string view, so that would have worked. The write would have worked, hopefully. I'm just like loading the game data files at the moment. So when we wrote the game data files, it would have worked because it just uses the string view, so it just writes bytes into the file, into the binary file. But when you load it, you've got to actually put it back into the string object. And they expected a string object of type W string, but it was an N string they needed, so I just skipped it. I think that was what was happening. We'll see. Back in 2 minutes, I'm going to sort this door out. Yeah, that's because I've just put in this N string thing, and obviously there's going to be a few loose ends that I forgot to do, including serialization. But hopefully this works now. So the font group had a string in it, so let's just... The shader group, sorry. So let's just check this still works, because it affects everything to do with strings. Okay, so str has got 16 bytes in it. So it's just going to put in... She's got shader group F there. Len is 12. That worked like a charm. Font group, sound bank, another sound bank, worlds. This was the one that was crashing. So the trigger regions specifically, so it read. So 40 trigger regions. Kind source. So it's the source that we're worried about here. Okay. So the room, the second one. There we go. And it's 64, which is what we specified it to be. So this, in theory, has created it on the heap. So we make a view, and then we put the view into the string. So not the heap, sorry. It'll create it in the SSO buffer, which it's doing right there. Brilliant. Let's see if we still crash. No, it's gonna load. There we go. We've gone from 151 to 149. So it didn't really do much. But what that means in theory now, if we go to the heap, that's the arena allocator. Okay, so this is the string converter. So, how do I want the string converter to work? Hey, Rizzy McRisden, how's it going? You alright? Because right now it has to allocate a buffer on the heap to convert a string. It would be... like, maybe we shouldn't do that. Maybe we should just grow a buffer. How would it probably couldn't do that on the stack. It's going well. I'm not really bug fixing at the moment. I'm working on memory. I'm trying to reduce dynamic memory allocation, which is considered slow. I mean, it's not very slow. It has side effects. It can, and it means that the game could end up becoming slow. If I get if the heap is carved, the heap is all the big memory block, and if I carve it into too many small pieces. So I give this bit of memory over here and this bit of memory over here, and then when something else wants to come along and it wants to get a bigger piece of memory, but the whole thing is lots of little pieces, it can't fit. So that's what I'm trying to avoid. So only really just a break from the gameplay, because I've been doing gameplay for 6 months. So I'm just having a little break. Well, I have to keep an eye on it, yeah. So I've actually put in some little stats on the top of the screen. So this is how much memory the game is using, 235 megabytes. And then these are the Allocs. So this is every time the game's asked for memory in a frame. So there's 149 memory allocations in a frame and 149 frees. So it's like allocated the memory and it's given it back. And then this free block count here is how much it's chopped up. So the higher a number, the more it's chopped up, the more the memory's chopped up. So I want to keep this low. So 49 is pretty good, and I don't want it to grow. So I can keep an eye on it now. I can just be like, well, if this ends up growing to a big number, I know that I've got lots of little bits of memory here and there. But because this isn't growing, it means that when new memory allocations come in, it doesn't have to go to the operating system to ask for memory, or go to the heap to ask for more memory. It can just take one of these free blocks instead, because it fits. If it didn't fit in any of the free blocks, it'd have to go down another routine and use more memory. So this is like recycling memory. So basically, like, memory comes back in a free, and then it goes and creates a free block. And then when a malloc happens and new memory wants to be created, it looks to see if it can grab one out of a free block first. Yeah, it's good. And I made a new river. That was just to test how it affected the memory, really, making the river. So yeah, I was going to suggest... So the string converter has to do a dynamic memory allocation, because it needs to allocate there. And it only needs to allocate 5 bytes, which is terrible, really. it should be able to get 5 bytes from somewhere else rather than the heap. That's carving it into a very little block, you know what I mean? Just 5 bytes. Really, the heap should be like kilobytes, really. So yeah, I need to figure out a way to do this here rather than having to go to the memory allocator to do it, really. Because it's only 5 bytes. So one way to do it would be this buffer, to give this buffer a little bit of memory itself. So then when it does this, it can just use the memory that's in the buffer already. It doesn't have to go and request more. Put breakpoints here. It's 5, 10, 15, 5, 5. It's all tiny little bits of memory we're having to dynamically allocate. I don't want to do that. So what I also want to know is what 2 type is. It's a string with 16 bytes in it. So I wonder if we can go so we can say like if 2 type will be SSO, which means it will fit in a string without doing any dynamic memory allocation. Now will be SSO is not static. It could be though. There's nothing stopping that from being static. So if 2 type will be SSO, then we need to do the allocation directly in the string. So this is 2 type result. So maybe we need to get the SSO buffer really. Maybe we can do it a different way. So we can do something like to type jar type buffer to type buffer size, like that. And that will give us a buffer to do it to. We can say, so we can go p buffer. It's null pointer, right? Do memory blocks have equal size? Do you allocate them? Use them to allocate any type of data. Are they bound to a specific type? So it's pages, and all the pages are of equal size, and they're like many megabytes. And then you request a size, and it like carves a little bit off the page. So you get the size you requested aligned, and then I do things like you get a little bit bigger because I have some guards on either side to check for memory corruption and stuff like that. But generally what it does is it carves up the memory block that you've allocated, the page that you've allocated. So they're all of different size, and they're just void pointer. And then, you know, you cast it to whatever type you want, what you've asked for. Yeah. But yeah, any questions is fine, don't worry about it. But yeah, all the pages are the same size. And I think they're around 16 megabytes each, I think. Something like that. So if you launch the program and do one malloc, you're getting 16, it's going to allocate 16 megabytes, even if you just malloc 1 byte. And that's because it knows that there's going to be lots of mallocs. So the second time you do a malloc, it doesn't allocate that page, it just uses the free page that it's got. So we're going to point to the buffer. So if it will be SSO with that size, then we can say p buffer is equal to buffer else strbuff grow to the size, and p buffer is equal to strbuff get data, like that. And then this becomes p buffer, right? And then we need to know so this is going to move the buffer across, or we want to just copy it across. So I could just do p buffer, which will do a copy. It'll copy the buffer. It'll want to move the buffer if it's not going to be SSO. Yeah, no problem. No problem. Yeah, so when you request a memory block, of say like a kilobyte, it'll give you a kilobyte plus a little bit. And the little bits are there just to check you don't write over the end of the block or no one writes into your block. So they're little kind of safety features, really. So you get a little bit more than you requested. So stream freezes. Stream might freeze. It's very hot in this room. It says I haven't lost any frames. It's possibly gonna freeze when I'm asking too much of the CPU. When I was like compiling all of my game data and stuff, it might just hog the CPU. Okay, so we want to move it in some situations. So we're going to say if p buffer is equal to the str buffer get data, we want to move it. Else we actually want to return to type p buffer len like that, which will do a copy. Doesn't know about p buffer for some reason. What's this? Cannot be const. It's fine. So this there's two of them. What's the problem here? Unexpected token buffer. Yeah, see you later, tester tech. So it won't let me create just a stack buffer. If I just do like char, does that work? So let's just go using char equals to type char type. This is all char, char, char. Char type. All right. Cannot create from initializer list to to type. So what is to type? BM string. It's because it wants it to be const. Maybe. Actually, we just have to pass the buffer in. That should work. Seems to like that. That's good. Tesla tick, if you're still there, I can repeat what I said. What was I talking about? I don't mind. So what we're saying here then is if we can do it all in SSO, then we'll do it all in SSO. And we won't do any dynamic memory allocation at all. Maybe that's what will happen. By SSO, I mean the small string optimization. So the strings have got a little buffer in there. So they actually own a little bit of memory and they don't always have to go out to the heap to get it. If we can fit the conversion in the buffer, then we'll do it in the SSO buffer. We'll do it straight in the buffer, into a buffer on the stack, rather than having to do a dynamic memory allocation. So let's just test it, a moment of truth. Okay, so quest. We want to go from quests from quests C string to quests W string. So it should be SSO. So we just return a pointer to this buffer. And we put quests in it. And then obviously this is only going to work if it's SSO. There we go. So we didn't do any dynamic memory allocation there. So are there any that aren't? This one. So full screen borderless window. So we're going to grow it by 27. So this does do a dynamic memory allocation. But then it moves it into the string. So it's not all lost. It's not a double memory allocation. All right. So that saves a nice bit of time. Well, that's a nice little optimization there. The small strings just get converted right here on the stack. Okay, happy with that. So let's go back to the heap and see what else there is. So this is in move mesh. We want 80 bytes, which is fine. Considering there's nothing in the mesh. So we're calling standard move mesh. So it's wanting to grow the array. That's all that this is happening. So the renderer has a meshes array. So the meshes array doesn't just get emptied then. Is there an end frame? Next frame. Empty. Tick. Render a tick. So the meshes do just get emptied. Gonna sneeze 1 second. Sorry about that. So the meshes do get emptied. There's 4. I wonder why we need to. So it's emptying a map. Meshes. What's going on here? What are meshes? Meshes are a map. Right. Because they're saying, well, okay, so this here could be an array. What we're saying is that these meshes belong to these canvases. So we're losing our memory reuse, I think. Well, so in add mesh, where was it? Where we're adding the meshes in? It was called move mesh, wasn't it? In the renderer, move mesh. So we're going to add it in. So I don't want it to do. So we're moving the array. Oh, I missed get space. What is the cap? Cap is 16, so it wouldn't have allocated anything. Well, let's try again actually. So empty it. It's moving. Well, yeah. Okay. I don't think there's really much we can do about that other than have it as a linear array instead of a map. So we'll say that's one that is going to be a dynamic memory allocation. There's not many of them. Okay, we have dynamic storage here in UI canvas. So this is renderer storage. So we can easily make this hybrid storage. Well, it's big though. This is where we create a new canvas. It's just because we're creating it straight there. We could put the canvas actually in the game, but this is only debug stuff though. So obviously setting up a canvas is quite a lot of work. Canvases are quite big because that's like where all the draw calls go, and all of the. So it needs to know what kind of canvas it is and stuff. So it's a game UI renderer. So what is the size of this? 8. Size of style. 836 in style. That's like a bunch of colours and stuff. And you go style.set, which is copying them all over. So it says this is still 8. Where is style? UI style. Size of this is still 8. I don't really believe that. It's not this, it's this. 1016. There's a lot of stuff in a canvas. So that is a significant dynamic memory allocation. That's fine. That's like a kilobyte of stuff. Lovely. So I'll keep going then. Fill vertex range in the canvas. Yeah, so it also needs to allocate, because we're not reusing a canvas. If you reuse a canvas, it can reuse all the buffers in the canvas. So this has to go through and do a bunch of allocations every single frame for the buffer. Make that static, and that means there's only one of them. Let's see if this saves a bunch of stuff. Not too bothered because this is only debug stuff really. But you know, seeing as we're working on it. I'm not really putting in any new things at the moment. I'm just going to work on what we've got before I start adding new stuff in. There we go, that goes down to 129. Doing that. So we'll leave that like this for now. May as well. Oh, it works fine like that. the proper way to do it would be to put this in the HUD state. But because it's debug stuff, well, we could put it in the HUD state. Do we have any other canvases? We'll leave it, it's fine. So end UI calls end and it calls add mesh to renderer. So this is going to do all of the moving the mesh and stuff. Render remove mesh. She said we were going to keep more move mesh, more move mesh, more move mesh. These are all decent. Allocs, look at that, 16k there. 2k. 74. So this is push immediate message. String builder. So I've had a think about string builder. If you're wanting to just limit the allocations that string builder, so we've got this thing called builder. We can actually just reserve. We already do reserve. We reserve what, so this is comes in, this is formatting strings, this. We reserve what comes in. This is given to us by the standard library of what it thinks the cap for the string will be. And it's never right, it's always too small. We could reserve just more, like 2 times the cap. So it thinks it's going to be 12. And then by the time we get to the result, which is here, I think. Yeah, it was 11. So that was alright. 11. 3. 36. 40. Like if we reserve twice as much as the cap suggests, no, we'll just leave it. So this is all push immediate message. This is a string thing using normal strings. Patch reflections, build reflections, patch reflections, array reflection tokens. So this is because we're wanting to how big are reflection tokens? Not very well, they are quite big. Got to merge these in. Size of reflection token 128, so that is quite significant. It should be better really to do this on temporary memory, I would say. Okay, temporary memory isn't a heap allocation. Nice one. Alright, I'm going to take 2 minutes. I'll be back, I just need to use the loo. Alright. Okay. So we're 132 Allocs at the moment. So there's patches now. Are on temporary memory, which is awesome. So it looks like a lot of it really is converting from the canvas, passing the canvas data into the renderer. Like we could speed that up if we wanted to. It's fine though. Don't really want to mess around with the renderer. Like all this stuff, all these Allocs are going. Whoops. Going from the canvas into the renderer. But they are like big, like 8K that one. 33K that one. It looks like loads of these strings Allocs have gone. So all this push immediate message, because that's building strings. So any kind of thing like a little bit of speed up I can see, or like a little bit of using less memory, fewer memory allocations is when we're building strings to just allocate more reserve in the string builder. Okay, so this is formatting a string again. Okay, so this is building array indices. Oh, that's where it needs to build up the index buffer. So this canvas is the game canvas. Yeah, this is the same stuff. Adding the mesh to the renderer. Converting the canvas to the renderer. Or passing the canvas into the renderer, I should say. You know, I think that's alright. So it started off with like 250 mallocs. And now we're down to 128. We sort of like got it down by half. Okay, cool. Let's have a quick look at dynamic storage. Let's see if anywhere is using a dynamic storage that we can. No one's using it. Let's have a look at lambda and dynamic lambda. Not dynamic storage base, no. Dynamic storage wanted. Wherever that is. There. So a few things are using dynamic storage. Animated rig storage. So what is this storage? Not used in the rig itself. Oh, we're selling it's a spine animated rig. So what is the size of spine animated rig? It's 168 bytes. What is the size of this? No, size of this 112. So if we made this some kind of hybrid storage, Yeah, no, I don't think we need to do that. Make it a bit big. Okay, so who else is using dynamic storage? The asset storage. Yeah, I think that's fine. Sprite storage, brush storage. The editor stuff I'm not so bothered about. Cutscene node has storage in it. That's fine because that's just allocated at the beginning of the game once. Dynamic storage, render storage. So that stores the renderer, that's just once. I think it's totally fine. So what about dynamic lambda? So the jobs run on dynamic lambda. So that means every job's dynamically allocated. We changed the DirectX version. DX run job, which takes an actual lambda. For 32 bytes. No dynamic at all. So a job queue. Oh, it's hybrid lambda 64. Okay. So that needs to actually change then. So when you do run job, it expects a hybrid lambda. Am I passing in a dynamic lambda? What I'm going to do is move these into the header. Not a lambda at all. Gjob queue. Where's gjob queue? It's in the app. So it's get job queue. Run job. So that was actually not a bug, but kind of a typo. It was dynamically allocating a job to possibly not have to dynamically allocate the job. So it's dynamically allocating a job, passing it to the job queue, and the job queue is probably taking that dynamic lambda and putting it on the stack anyway. Wherever it was putting it. Alright, so let's just have a quick look at the notes. Not here. Where do I keep the notes? Yeah, this one. So there we go. Speed up pathfinding NPC instance system. Ooh. They need to go away. So we've got speed up pathfinding and NPC instance system. Speeding up pathfinding is probably fairly straightforward. NPC instancing system is gonna be quite hard. Possibly. Speeding up pathfinding is self-explanatory. Pathfinding sometimes stalls the game. There are a couple of options. Like I've deliberately left it on the game thread to stall the game because it will force me to keep it fast, but eventually it is going to go to a background thread. So I think we will work on it to try and get it a bit quicker on the game thread, and then possibly now is the time to put it onto a background thread. So I might do both of those things. So pathfinding just works in the background and just reports back when it's finished to the NPCs. You know, the NPC's like, where do I go in the game world? And then pathfinding goes, give me a second. The NPC will just do something else, and then it'll go, here you go, and it's worked out in the background, rather than stopping the whole game to try and work out where to go. Alright, so this might be and the other thing's the instancing system. So I want to be able to put two instances of the same NPC on the screen at once. I want to be able to do that. Have them be completely independent. Like I want to just program them once. But then just have two instances on the screen at the same time with all, you know, cloned behavior and everything. And that's going to be more difficult to do. But I might want that for gameplay. Like, you know, you can imagine a scene where you've got the NPC comes into contact with themselves. And I also want it for combat because I want more than one of the same type of enemy at once to fight. Great, flies just come in the room. Oh, great. We'll work on the pathfinding first. What I found out, there's a couple of ways I think I can speed it up. But anyway, down to 128 Allocs per frame. Which is really not a lot. So this is a debug build. But let's just take off VSync and see how fast the game runs. And then we'll do a release build maybe and do it. So in debug it runs at 170 frames a second, which is alright. There's quite a lot going on. Got the river, all the lights and stuff. Let's do a release build. I haven't done a release build for a while. Might take quite a long time to make a release build. I don't really want to start this finding optimization thing today, because it's right at the end of the day. There's only 15 minutes left. So we'll do a release build and we'll just see how quick it is. And then tomorrow we will come in and we will speed up pathfinding. That's quite a lot of work, that. I worked on it all the weekend. I worked on it Friday afternoon, all the weekend, yesterday and today. That's good. We might make a mono build for release as well. We'll test if there's any performance differences. In theory, with the mono build stuff, the optimizer can see a lot more of the code at once. So you'd think it might be able to do a bit more optimization. Ugh. Maybe. Yeah, these release builds take a while. So what I'm thinking for speeding up the pathfinding, go to the A star file, which is where the pathfinding is worked out. When we call where are we? Get neighbors. I think this is the one that we're using combat. We need to basically cull out ones that aren't in the room. So the room's got a bounds, and I don't think this respects the bounds of the room. So it might try and explore paths way away from the room. And that's what's happening when it's stalling. It's just exploring too far away. Whereas if we just get a list of all the tiles in the room, And we just have to check that each of these neighbours is in that list. So it would be 8 checks, 8 binary searches per node. And we'll see, there's a be a trade-off, because obviously that work has to be done, the 8 binary searches. We could actually do a rectangle intersection if all the rooms are going to be kind of rectangular. So we could do a point rectangle intersection. We could try that. So it'd be 8 point rectangle intersections as well. And we can basically say like, we have a search space there. So we'd pass in like, this is what it does with the search space. This is for a nav mesh, this. So we'd have to actually add in, well, and it'd be this one. The search space for this one would be all the tiles in the room, which would mean, it basically means automatically creating a default nav mesh for the room. That's what it means. That's all it means. So if we create a default nav mesh, so if there's no nav mesh, well, we create a default nav mesh for the room. And if you don't specify what nav mesh you are searching on, because you can do that if you want, but if you don't, you use the default nav mesh. Hopefully that speeds it up. That's what we'll work on in the morning tomorrow. So we'll just be running this code instead of this code, and the search space would be the default nav mesh. So that basically means in the level room, we would have a search space in here, which would be the default search space. We could just get the room that the character is in and send that in. It's just a list of numbers, really. Depends if the binary search is going to be faster than just doing a check. It's probably going to be faster to just do a rectangle point check because it is an integer. That's only a few integer compares. In which case, we already have the room bounds already. So we just test. We just test that the neighbour is, or the NI is in the room, in the current room. Can't test that right now because we don't pass in what room we're in, I don't think. So we'll have to work out how we pass in. So what is a search space? It's an array of index type. Yeah, we just have to pass in, like, we have to just set a maximum bounds on the actual A* search, I think. That's another way to do it. I think that might be quicker actually than doing the binary searches. Obviously that means that a room can only be round, a room can only be a rectangle. At least the search space for the room. Think about these search spaces here. is that these search spaces can be any shape, so you can draw them in the editor, and you can say, look, we just want you to walk in this space. We don't want you to pathfind over this space. Whereas if we did a bounds, if a room was a really weird shape, like a U shape or something, I don't know. We'll try all these methods out. Alright, we're about done a release build. That took a long time. 9 minutes, blooming heck. The mono debug build is only 1.5 minutes. Okay, well, let's hope it runs. There we go, 600 frames a second. So that is 10 times as fast as I need it to be. It goes to, if you do it to full screen there, borderless full screen window, not borderless, it goes up to 700 frames a second. I mean, this is nothing in this room, so it's over 1,000 frames a second. This room's got a bit of stuff in it though. What about this one? 800. So it's definitely fast. There's a little bug. If you're talking to him, he goes off. Not necessarily a bug. We're drawing a bunch of stuff here. Draw quest objective. Scope timer message. So we've got perf there. This is the pathing. I think we actually dealt with this. $700 frames a second. Woot Dragon, hey, how's it going? You okay? Right at the end of the day. I've just been working on memory stuff all day. Getting the allocations down. So we got them from about 250 Allocs a frame down to 128 Allocs a frame now. Which is pretty good. And the game's running at 750 frames a second. 1 millisecond it takes. This is an old computer. That's pretty good. I'm just having a bit of a break from gameplay programming because I've been doing it for like 6 months. So I just worked a little bit on. I wanted to reduce the amount of dynamic memory allocations, not really for speed because the heap's pretty fast. It's avoid fragmentation and put some like stats up. Like there's only 39 blocks in the free list. So obviously I can monitor fragmentation. If this goes up, this starts to go up to a ridiculous number, it means there's quite a lot of fragmentation in the heap. And then 235 megabytes, that's how much the game uses at the moment. And there's 128. And they can check Allocs to freeze per frame. So you can see if you're Alloc'd more than you're freed. And also, this is the net Allocs. So if this goes up, you've got a memory leak. Potentially. So it's good, it'll help me monitor memory leaks and things. But there doesn't appear to be any at the moment. So yeah, it doesn't use much memory, 235 meg. Jump table obfuscation. Have I heard of it? No, I don't think so. Not those two terms together, anyway. Obviously, I know jump table and I know obfuscation, but not together. Yeah, it sounds interesting. Time to reverse, like stop people reverse engineering your code. Is that what you mean? Or the program? Cool. But no, I've not heard about it. Convert a func memory address. Well, look at that. Ah, right, okay. Yeah, so that's cool. Clever. Very clever. Nexon. Oh, really? That's quite clever. What? I wonder how you get it. Obviously depends on what these are, doesn't it, to be able to get the actual thing back again. Yeah. Yeah, so it's going... It's like a kind of a hash and then a return. An unhash, or whatever. Layer XOR key. Layer 1 XOR key. Oh, you mean so you can use the same key? Oh man, my brain's too Cornwally at the moment to actually try and work it out. That sounds cool though. Yeah. Awesome. Clever. Yeah, alright. Go back to this. Does it have like... It'll have like a symbol table or something. Or maybe not. To debug it at runtime. That sounds cool. Right. Anyway, Root Dragon, I've got to go now because it's 3:05. Nice to see you though. I'm back on tomorrow. Tomorrow we're going to work on pathfinding a bit. A little optimization I'm going to use with pathfinding. And then we might move it onto a background thread after that. Draw a line under it. Yeah, XR encrypted. Cool, cool. Right. I'm going to have to head off. I'll see you maybe tomorrow. I'll see you on the internet somewhere. Work